In today's video, I want to go through linear regression, which is a methodology for showing relationships between two variables. Now, the methodology is not restricted to two variables. Visually, we're restricted to it, but the math certainly is nowhere close to restricted by the number of variables. First thing I want to do is I want to look at a picture of these two variables to see if there's a relationship to look for. That seems like a reasonable question. So I'm going to draw a dot chart, and on my x-axis I have the number of construction permits, and on the vertical axis I have the amount of sales. And if you look at that, it looks like this thing, there might be a relationship passing through these points that I could use to forecast tile sales given what I see in construction permits for a month. The last module we introduced a way to do the linear regression. In module 7, we're taking that linear regression and we're saying, okay, well, let's look at these variables that are not time series variables. And then without the time series attachment, we have ways of measuring how well something fits. So did my regression do a good job? We define each of these variables in the module and in the chapter on page 520. And what I want to do is show you how Excel can quickly give you these variables. So let me, well, you know what, it doesn't matter if I choose that or not. Let me go in now and I'm going to go to Data and Data Analysis. Now, there's a chance that on your version of Excel, when you go to Data, there's nothing out here to the far right. That's because these objects out here have to be turned on. And the way you would turn them on is to go to File, Options, Add-ins, Excel add-ins, and you would need to put a check mark between what you want added in. Right now, what's important for us is data analysis or the analysis tool pack, and you click OK, and this will then show up on your machine. So I want to click on the data analysis tool pack, and I want to find the word regression, and then click OK. So what regressions are doing, or what this function is doing, is saying, okay, go and find the y values. So it's walking me, it's hand-holding me through the analysis process. Next thing it says is highlight the x values. And then because I highlighted the labels, see I've got B2 and A2 in here, I want to tell Excel that I included the labels. Now that helps in a way that I will point out here in just a minute. I'm not going to check any other boxes except this output range, and then I need to tell Excel where to place the information. And then just push OK and a big old table pops up. Okay? So I want to figure out how this information can help me. So first thing we defined on page 520 is a sum of squares total. If you remember, this is what if I just use the mean to forecast values for sales? Well, might do a good job, might do a lousy job. Well, let's try to figure out whether it would do a good job or not a good job. And the R-squared is eventually what tells us whether it's going to do a good job or not. But let's get this sum of squared total. All right, first off, the sum of squared total in our picture lives down in this ANOVA table. And it's this 141.83 and then 4 zeros. That's my sum of squared total. Now, what about the sum of squared of the regression? So what did the regression explain? Well, that's the sum of squared regression. So regression, sum of squared. So SS, sum of squared, regression, regression. So there's my regression sum of squared. And then what about the error sum of squares? What are those things that the regression don't explain? And well, that one is coming in right here as the residual sum of squares. Okay. R squared is just the ratio of the regression sum of squared to the total sum of squared. Now, when I push return, you're going to notice that that number already lives up here. So why did I do that? I did that to show you that all the data we need is being given to us here in this table. We just need to learn how to read it. Now, one thing that is not given in this table is the correlation coefficient. But we can construct this. There's a C-O-R-R-E-L, correlation coefficient. It just needs the numbers from each array. And then I get a number between 0 and 1. By the way, these two numbers are connected. It's just a happy coincidence. They won't be later when we do a multiple regression. So what does this one tell me? Well, is it telling me anything new? And the answer is yes. The positive sign is telling me that I have a positive relationship, which I think we saw, right? When we drew this picture, it kind of looks like if there is a linear relationship, it should have a positive slope. All right, now this standard error of the estimate. This thing was given as a square root of the sum of the squared errors. So square root of the sum of the squared errors divided by the square root of n, so the number of observations, minus 2, which happens to be the number of variables. There are 2 of them. Okay? So I push return, and looks like I still need to go in and do a little bit more work. Okay, Excel put it together for me. Now if you do notice, the standard error is already in my output. So the r squared the standard error and these regression, residual, and total sum of squares are all part of my output. And so, yes, you can use the formulas on page 520, and you probably ought to a couple of times just to get the feel for what you're doing. But you can also use this regression tool in Excel, and then you can go in and say, okay, do I have a good fit with my regression analysis? The r squared at 92% suggests, yeah, it's a pretty good fit. The correlation coefficient says it's going to be a positive relationship, and it's close to 1, so once again, yeah, it's probably a pretty strong correlation. The sum of squared total, these numbers are not giving me anything of interest right now. Neither is this one right now, but I had to calculate some of these totals in order to get the totals I was interested down here. So hopefully this is helpful at explaining what's going on in Module 7. I may give you one more quick video regarding multiple linear regression, which is actually, you can use this exact same process. Oh, I told you, notice how the names, intercept, and construction permits are showing up. So R is saying, because I told it to, that the construction permits are the X values. So here's the intercept on my regression, and here's the slope term on my regression. Anyway, I will give you another video on multiple regression. Hopefully this helps.